好，大家好，今天讲就是这个串联机器人的第二部分，就是常见的串联机器人的几个形式，也就是说，串联机器人一般常用的一些几个形式啊，我们可以看一下啊，这个有哪些。首先是球坐标啊，这个我们看过了是吧？就绕这个走转动，这是unimate 是吧？然后再绕这个轴转动，绕这个轴转动，绕这个轴转动。啊，然后这是圆柱坐标的，我们也讲过了，这个是绕这个数字转动，然后伸缩，然后这个这个是直角坐标的，一个轴、两个轴、三个轴的这个移动啊，这个是互相独立的，可以看一下，这直角坐标。这个是龙门式的直角坐标，这个严格意义上来说应该不属于串联机器人啊。这个如果这里这个方向假设有两个带动它啊，两个移动符带动它一起就沿这个横向这个一个嘛还有这等等啊，这个四下啊等等，就是这个是龙门式的直角坐标那么这个刚才说不是严格意义上不是这个串联机器人，应该是可以说是混联啊，混联，这是关键性的这个包括我们说的 Scala 呀等等，前面这 Scala 比较应该是很著名的，这里没有说，就是把这个Scala 是这个关键性的一种嘛我们可以看一下这个里面有个视频可以看得清清楚楚啊。
There are four main types of robotic arm geometry: rectangular, cylindrical,
可以看一下
spherical, and jointed spherical. Robots with rectangular arm geometry use Cartesian coordinates and move linearly along each of the X, Y, and Z axes. This type of movement is also called 3P geometry, where the P stands for prismatic or linear motion. This type of geometry is most commonly used with pick and place or large overhead mounted robots. Rectangular arm geometry robots can only move linearly in each direction. An overhead crane robot is a good example of this type of motion. It can move forward and backward, left and right, and up and down. Robotic arms that use Cartesian coordinate geometry generate a rectangular work envelope. Rectangular robotic arms have the simplest geometry and control system and are typically used in material handling operations. Cylindrical arm geometry robots move linearly in two directions and rotate in one other. Since this type of robotic arm moves in two separate prismatic or linear directions and rotates in one direction, it's given the designation of R2P, where the R stands for rotational. This type of robotic arm is most often used in machine tending, assembly, material handling, and palletizing operations. Robotic arms with cylindrical geometry move linearly in two directions. Vertical linear motion is called stroke. Horizontal linear motion is called reach. And rotational motion is called swing. Cylindrical geometry robots have a cylindrical work envelope. The advantages of this type of work envelope is a robotic arm reach that is deep at both the top and bottom of the stroke. Additionally, the robot structure allows for quick movements with high repeatability, a smaller use of floor space, and a larger payload capacity due to structural rigidity. Spherical arm geometry robots can rotate in two directions and move linearly in one, and thus are given the designation of 2RP. The robot has base rotation, shoulder rotation, and prismatic or linear motion at the arm. This type of robotic arm is most often used in machine tending, material handling, welding, painting, coating, and assembly tasks. Robotic arms with spherical geometry have rotational movement in two directions, rotational movement at the base and rotational movement at the shoulder. Spherical arm geometry robots also have linear motion in one direction, typically the reach of the arm. Spherical arm geometry robots have a mostly spherical work envelope at their outer reach, but are limited by the linear reach of the arm and the rotation of the shoulder joint. The shape of the robot's inner work envelope is almost conical and does not become a sphere until the arm extends. Spherical arm geometry robots typically have a very long reach and have proven their performance in industrial applications. However, their high cost, large use of floor space, and lack of flexibility compared to jointed spherical arm robots make it hard to justify in most industrial applications. Jointed spherical arm geometry robots have rotation in three directions, use revolute coordinates, and are given the designation of 3R. They are one of the most popular types of robotic arms and most accurately mimic the movement of the human arm. Robotic arms with jointed spherical or articulated geometry rotate on at least 3 axes. Left and right movements are provided by rotation at the base. Horizontal movement is provided by rotation at the shoulder. And vertical movement is provided by rotation at the elbow. Except for very close to the body, the work envelope of a jointed spherical robotic arm is almost entirely spherical. The advantages of this type of work envelope is a robotic arm with very deep reach, minimal floor space use, and high positioning mobility of the tool end arm. Due to its mechanical complexity and the complexity of its controller, this robotic arm typically comes with a higher hardware cost and requires skilled technicians.
这是它的工作空间啊，这个就是我们看到这个轴的啊。那么这个是3轴转台，刚才我们看到这个3平移的这个龙门式的，这个其实3转动的，但是也又相当于是一个混联，严格意义上混联啊。但是我们放在这里的话，给大家看一下，它是用于什么呢？用在这个硬件载环导引头制导测试啊，这导弹一些测试啊，用的很多啊，像哈工大以前是他们有老教授，像吴胜林啊、赵克定啊，老师，他现在早就退休了，80多岁了，他们做的应该是很早。这个是世界上第一台啊，麻省理工的45年，我们65年研究第一台。那么哈工大就是赵克定老师他们团队就是研制了很多，当然后面现在有他学生在做，也当然这还有企业啦，还有研究所也有很多做啊，这个就是给大家展示一下，就像这个有这些，当然它这个用3轴转台啊，就可以说是这个就是我们这个简单的介绍一些结构形式，